Today we'll be covering Le Chatelier's principle in AP chemistry. It's important to understand the definition of Le Chatelier's principle. If a constraint is applied to a system of equilibrium, the equilibrium will shift so as to counteract the effect of the constraint. While solving these problems, think of this tip. Think of a balance scale. If one side is lopsided, the other way to rebalance it is to add more of something to the other side. So the first factor in Le Chatelier's principle is concentration change. When the concentration of a side is increased, the equilibrium shifts away from that side. So let's say, like in a scenario, if moles of A are added to reactants, then equilibrium shifts towards the products. Conversely, if moles of C are added to the products, then equilibrium will shift left. Below is representation if more of A is added. So as you can see, the equilibrium shifts right to rebalance the equilibrium to favor the products. The next factor is temperature change. If the heat is increased in an equilibrium system, the equilibrium will shift towards the products if the equilibrium is endothermic, and towards reactants if the equilibrium is exothermic. So the first problem that you need to solve is this. If delta H is -1 kilojoules over moles, then adding heat to the system will shift the reaction where? So the answer to this is, since delta H is negative, then the reaction is actually exothermic, and heat will be a product in this reaction. And if more heat is added to this reaction, then equilibrium will shift towards the left to rebalance the reactants. The next factors to consider are pressure change and volume corollary. For pressure change, if the pressure in an equilibrium system increases, the equilibrium will shift towards the side with the fewest number of moles. In the volume corollary, if the volume decreases, the pressure increases, and the equilibrium will shift towards the side with the fewest number of moles. So let's say if pressure is added to the system in the equation below, the equilibrium will shift towards the products because it has the least amount of moles. So this is the second problem that we want you to solve for the equilibrium pressures for the reaction. In this problem, it tells you that pressure A has 1 atm, pressure B has 2 atm, pressure C has 2 atm also. If all of A is removed from the system, what are the pressures of each substance after the system re-equilibrates? So pause the video right now and solve it for yourself. Alright, so the first step you have to do is, with the given information, solve for Kp value. So the pressures of the products will be over the pressures of the reactants. So that will equal 2 atm times 2 atm over 1 atm. And that gives you a value for the Kp. The next step is to create a BCA chart. Since it tells you that all of A is removed from the system, then you start out with 0 atm for pressure A. And you just include the 2 atms for both B and C because that's given. And because pressure A is 0 atm, then it needs to rebalance according to Le Chatelier's principle. So the reactants are favored in this reaction. So because of that, you have to do plus X on the reactant side and minus X on the product side. So in the after section, you'll have X for pressure A, 2 minus X for pressure B and C. And the next step after that is to set up the equation of Kp equals the products of the pressures over the reactant according to the BCA chart. So you'll have 4 equals 2 minus X times 2 minus X, which is basically like 2 minus X squared over X. And simplifying that further, you get X squared minus 4X plus 4 equals 4X. And that equals X squared minus AX plus 4 equals 0. And you find that X equals 0.536 or 7.46. But you do not choose 7.46 because if you plug it back to the BCA chart of 2 minus x, then you'll have a negative pressure, and that's impossible to have. So your answer for x is 0.536. And then solving for the individual pressures, which it asks, you just plug in x in the after section of x. So 0.536 would equal the pressure of A, and 2 minus 0.536 would equal the individual pressures of B and C. So now let's review. So solve these questions out for yourself and pause the video. And then these are the answers. Thank you for joining our discussion.